We are in Unit 3 and we start out with the fun thing called chain rule. Now, chain rule is when you are asked to find the derivative of a function within a function. So this is the way I view it. You're going to have some type of inside stuff. So let me write that out. Some type of inside stuff. And you're going to have some type of outside stuff being outside. So function within a function. Now, if I were to compare this to this, my outside stuff would be to the fourth power. My inside stuff would be 3x squared plus 5. So this is how I view the chain rule. I know different teachers and different professors are going to handle this differently. They'll have their U's or they'll have their V's or they'll have the F's and G's or whatever. But I like to view it like this. When you take the derivative using the chain rule, you take the derivative of the outside stuff. You keep the inside stuff, but then you multiply everything by the derivative of the inside stuff. Take the derivative of the outside stuff, keep the inside stuff, multiply everything by the derivative of the inside stuff. So how do I handle that with this guy right here? Well, the outside stuff is to the fourth power. So me taking the derivative of the outside stuff is going to involve me bringing this 4 down because I'm using power rule and then subtracting 1 from 4, giving me 3. Okay. You are then going to keep the inside stuff. And the inside stuff was 3x squared plus 5. All right, let me scooch this in because I didn't leave myself the most room. But I'll be all right, because then we multiply everything by the derivative of the inside stuff. The inside stuff was 3x squared plus 5. So the derivative of 3x squared is 6x, and then plus 5 is nothing. Now the last thing that I want to do is mess with this stuff to the third power. I'm not going to use the Pascal's triangle binomial mess that you learned in pre-calc. No thank you. I'm going to leave that the way it is. But what I'm going to do is multiply 4 to 6x, giving me 24x. Then I'm going to multiply that 3x squared plus 5 all to the third power. And that, ladies and gentlemen, is chain rule. Chain rule, the math teacher go method. I know a lot of people, again, teachers will use F's and G's and stuff like that, but I would rather view it from this, I don't know, more practical point of view because that's how my little pea brain works. It just works for me. Okay? So there you have it, chain rule. Find the derivative of h of x equals e to the stuff. Now, this is going to use the chain rule. The chain rule is a function within a function. All right, so you are going to have inside stuff and outside stuff. The way the chain rule works is you take the derivative of the outside stuff. You keep the inside stuff the way it is, but then multiply everything by the derivative of the inside stuff. So the function within the function, okay? Now, the within the function part is going to be you. You are my inside stuff because normally it's e to the x. Well, instead of x, I have all of that junk. Okay, my outside stuff is going to be e. So me taking the derivative of the outside stuff changes absolutely nothing because the derivative of e to the stuff is still e to the stuff. Me keeping the inside stuff so far changes absolutely nothing because I have 5x squared minus 3x, so nothing has changed up until this very moment. Now what I do is I multiply everything by the derivative of the inside stuff. That inside stuff was 5x squared minus 3x. So the derivative of 5x squared is 10x, and the derivative of minus 3x is minus 3. So what was that, h? So h prime of x is going to equal u times u. And it looks like they don't want me to do much more than this. It looks like all I have to do is just circle that and say, yeah, my answer is D. All right, so again, you know it's chain rule when you have a function within a function. And usually since you have e to the x and you don't have e to the x, you have e to the something else, that indicates chain rule. And the inside stuff was you replacing x with all this junk right here. And so there you have it, chain rule. Fun stuff. Find the derivative of k of x equals ln of 7x cubed plus 2. This is chain rule because normally I have ln of x, but instead I have something inside that normal x, so a function within a function. The way I view chain rule is when you take the derivative of a function within a function, you have stuff on the inside and you have stuff on the outside. You take the derivative of the stuff on the outside, you keep the inside the way it is, but then multiply everything to the derivative of the inside, like so. All right, so me taking the derivative of the outside would be me taking the derivative of ln, or ln of stuff. So what I'm going to do is the derivative of the outside is going to be the derivative of what ln would look like, and it would look like 1 over whatever the inside is. Now you keep the inside exactly the way it is. So I'm going to write out 7x cubed plus 2. So again, the derivative of ln is 1 over stuff. Keep the stuff exactly the way it is. You don't change the inside until now. Multiply everything to the derivative of the inside. The inside was 7x cubed, so let's turn that into 21x squared. The derivative of plus 2 is nothing, so you have that. So basically, one more step involves me just saying, all right, well, 1 times u is going to be 21x squared. 21, of course, 9 plus 10. 7x cubed plus 2. And that's what k prime of x is going to be. And that would be, it looks like u. A. All right? So, yeah, chain rule. Fun stuff. Find the derivative of g of t equals sine of 2t cubed plus 4t. All right, so what I have here is chain rule. I have a function living inside another function. Normally I have sine x, but instead of sine x, I have sine of stuff. So u would be my inside and sine would be my outside. Now the way I like to view chain rules, I like to view it as inside and outside instead of f's and g's like normal professors or teachers might do. You take the derivative of the outside stuff. So I would take the derivative of sine, but then I would keep the inside exactly the way it is. And when I'm done that, multiply everything to the derivative of the inside stuff. Okay, so what does that look like here? Well, g prime of t is going to be the derivative of the outside. The derivative of the outside is the derivative of sine, so cosine. But you keep the inside exactly the way it is. 2t cubed plus 4t. Then multiply everything by the derivative of the inside stuff. The inside stuff was 2t cubed, so the derivative of 2t cubed is going to be 6t squared plus 4, because 4t's derivative is just 4. And it looks like that's all I need to do here. So which one matches up? Is it C? It is C. So the derivative of sine of stuff changes the sine into cosine, keep the stuff, but then multiply everything by the derivative of the inside stuff, which is going to give me U. And it also gives me C, because that's the letter of the alphabet. Like and subscribe. Chain rule. If y equals cos 4x, then the instantaneous rate of change at x equals pi over 12 is ... Instantaneous rate of change. What does that mean? Oh, the derivative. So what I'm going to do is I'm going to find the derivative, plug in pi over 12. Ooh, this is cos 4x, not cos x. So I'm going to have to use the chain rule because I have a function living inside another function. So the way I view chain rule is you have outside stuff, you have inside stuff. You take the derivative of the outside stuff, keep the inside stuff the way it is, but then multiply everything by the derivative of the inside stuff, like so. Okay, so let's do that. Y prime is going to equal the derivative of the outside stuff. So the derivative of regular cosine is going to be negative sine, but you keep the inside stuff the way it is. Okay. Multiply the whole thing by the derivative of the inside stuff, which is going to be me multiply the whole thing by the derivative of 4x, which is just 4. Let's clean this up a little bit. So let's bring that 4 out front, negative 4 sine 4x. Now what I have to do is I have to find what happens when x is pi over 12. So y prime of pi over 12 is going to be negative 4 sine 4 times pi over 12, which is going to be negative 4 sine pi over 3. You know from pre-calculus that sine of pi over 3 is going to be root 3 over 2. So let's write that out. And I'm going to multiply negative 4 to that. Okay. And really the only thing that happens is, the negative 4 and the 2 simplify to negative 2. So negative 2 root 3 is going to be my guy. So this required chain rule because I was being asked to find the derivative of something where it's a function within another function. Chain rule is to take the derivative of the outside, keep the inside, multiply everything by the derivative of the inside, do some math. The answer is negative 2 root 3. Chain rule. What is the derivative of y equals negative 2x cubed tangent of x over 2 with respect to x? Ladies and gentlemen, this is product rule, but as we do product rule, we're going to find out something else. Now, remind yourself that product rule says the derivative of u times v is going to be the derivative of the first guy times the second guy plus the derivative of the second guy times the first guy. So let's take this one step at a time. U is going to be negative 2x cubed. No craziness there. V is going to be tan x over 2. I'm not looking forward to what's about to happen. U prime is going to be power rule. Drop the 3 down, multiply it to negative 2, so negative 6, and then subtract 1 from 3, x squared. V prime is our good old friend, the chain rule. So in this problem, even though it's 3.1 and you're thinking, isn't 3.1 chain rule? Why is this guy using product rule? Well, sometimes you have to do both. And in this case, you do have to do both. Now, let me remind you what chain rule is. With chain rule, you're going to have some type of outside stuff, and then you're going to have some type of inside stuff. A function within a function. What you do is you take the derivative of the outside stuff. You keep the inside stuff exactly the way it is, but then multiply everything by the derivative of the inside stuff. So me taking the derivative of the outside stuff is me taking the derivative of tangent, which is secant squared. Keep the inside stuff, x over 2, but then multiply everything by the derivative of the inside stuff. Now, x over 2 is the same as 1/2 x, so the derivative of 1/2 x is just 1/2. So maybe cleaning this up in one more step is going to be secant squared x over 2 all over 2. All right? So it's not going to be pretty, and it's going to be a lot of fun. So now we have to do power rule to put it all together. I'm sorry, product rule to put it all together. Y prime with respect to x is going to be u prime v, so negative 6x squared times tangent of x over 2 plus v prime u, so secant squared x over 2 all over 2 times times u, which is negative 2x cubed. So the 2's cancel out, and one more step is me not changing u at all, negative 6x squared tangent x over 2. That's negative, so let's make it minus, and let's bring the x cubed out front. X cubed secant squared x over 2. So in this problem, we started out by thinking product rule thoughts, because that's what you're supposed to do. And while doing the product rule, you realized, oh, I have to do chain rule too. We're in this section. Oh, it's not going to go away anytime soon. And friends, it's not going to go away anytime soon. That's how calculus works. It scaffolds. That's what the word we use in math teacher language is. It scaffolds. Hope you had fun. Like and subscribe. If f of x equals e to the 3x times 3x minus 4, find any x values where a horizontal tangent line exists. So wherever a horizontal tangent line exists, that happens when your derivative, because, tangent lines, the slope of a tangent line is the derivative. So I want the derivative. And if it's horizontal, that means the slope is 0. So I care about when the derivative is equal to 0. So I've got to take the derivative of u. And this requires product rule. So I'm going to call u e to the 3x. I'm going to call v 3x minus 4. Now you might be thinking, this is 3.1. Why are we doing product rule? Well, here's why. Because now I have to find u prime of e to the 3x. Boys and girls, that's chain rule. You have a 3x living inside an e to the stuff. So this is chain rule, a function within a function. The way you handle chain rule is you take the outside stuff, which is e, and take the derivative of it. So what's the derivative of e to the stuff? E to the stuff. Keep the inside stuff the way it is, but then multiply everything to the derivative of the inside stuff. The inside stuff is 3x, so the derivative of 3x is just 3. So the derivative of e to the 3x is 3 e to the 3x. Nothing crazy. The derivative of v is going to be the derivative of 3x, which is just 3, minus 4, which is nothing. So that ended up nicely. That's power rule stuff. So f prime of x is going to equal u prime v. So this is power rule. So product rule, I'm sorry. If you forgot what product rule is, let me just write it out. U times v is going to be u prime v plus v prime u, the derivative of the first guy times the second guy plus the derivative of the second guy times the first guy. So the derivative of the first guy is 3 e to the 3x times the second guy, which is 3x minus 4. Ugh, this is not going to be pleasant at all. Plus the derivative of the second guy, which is 3 times the derivative of the first guy. So actually, I take it back. This is not so bad. Or as Eminem would say, not so bad at all. Okay, this is what I have here. All right, I need to now set this equal to 0. I have two factors here, u and u. And in both of these, I have 3 e to the 3x in common in both. So I'm going to pull out 3 e to the 3x out of both of them. When I do that, okay, I am left with 3x minus 4. And since for this guy, I completely pulled the 3 e to the 3x out of the whole thing, plus 1. So that's going to equal 3 e to the 3x times 3x minus 4 plus 1. That parentheses is useless. Minus 4 plus 1 is minus 3. Now, using the zero product property, my job is to find any x values where the horizontal tangent line exists. Okay, so I'm going to do zero product property and set u equal to 0. So 3 e to the 3x equals 0. And then in a different color and with a little less space, 3, and I could have pulled out a 3 if I wanted to, but it doesn't really matter. It's too late now. Minus 3 equals 0. Okay, so that's going to be the easy guy. That'll take me a couple steps. This, not so much. If I divide everything by 3, though, I now have e to the 3x equals 0. Okay, what I'll do is let me scooch you over. Let me drop down that 3x by taking the ln of both sides. So ln of both sides allows me to cancel out the ln of e, leaving me with just, and let me write it up here, 3x. Now, here's the tricky part. The ln of 0 doesn't exist. It's undefined. So after all of that, we get nothing here. That was great. That was a waste of time. But that doesn't mean we're not done. See, we have this other guy over here that we need to add 3 to, divide by 3, and then you get x equals 1. So after all of that, x equals 1 is going to be the only part that is going to give us a nice flat slope if I were to have it graphed here. So yeah, kind of a tricky problem, kind of a sloppy problem, but yeah, that's how we could use chain rule to answer some real life type questions. Fun! When f of x equals ln of 1 over root x, f prime of e squared equals what? Well, this is going to involve chain rule, boys and girls. With chain rule, you're going to have some outside stuff, you're going to have some inside stuff. And the way you handle chain rule is the derivative. Using the chain rule is going to be the derivative of the outside stuff. Keep the inside stuff exactly the way it is, but then multiply everything by the derivative of the inside stuff, like so. So I'm going to do that, and then when I'm done, plug in e squared, see what happens. Now, I'm going to rewrite this. Because if I'm going to have to take the derivative of 1 over root x, I'm going to have it written as x to the negative 1/2 so I can do power rule and not have to overthink anything. All right, see what I did? So now here's my new outside stuff. And here's my inside stuff. Okay. So f prime of x is going to be me taking the derivative of the outside stuff. The derivative of ln is 1 over x, but I'm going to keep the inside stuff, so 1 over x to the negative 1/2. I'll clean that up in a little bit. Okay, or maybe I won't. You can't tell me what to do. I'm going to multiply everything by the derivative of the inside stuff, which has me bringing negative 1/2 down, and then subtracting 1 from negative 1/2, giving me negative 3/2. All right, so let's rewrite this a little bit. This is going to equal 1 over, since that's a negative square or negative half, that's going to look back to the way it used to look. Okay, so in the original problem, now it's back to that. It's just now in the denominator. I'll fix that in a minute. I'm going to multiply everything to negative 1/2, so negative 1 over 2. Since this is going to be x to the negative 3/2, I would make it x to the positive 3/2 on the bottom, or the square root of x cubed. Maybe one more step. 1 over a fraction is just the reciprocal, so you look like that. So square root of x times negative 1 over 2 square root of x cubed. Now I feel comfortable plugging in e squared, so you are going to be the square root of e squared, I'll clean that up in a minute, times 1 over 2 the square root of e squared cubed. Don't forget that negative out front. I think I wrote it but didn't say it. Okay. So one part at a time, the square root of e squared is just e. You are still negative, you are still 1. Let's do this in one swoop. Okay. E squared cubed is going to be e to the 6th. The square root of e to the 6th is e to the 3rd. So 2e to the 3rd. Okay. So I have an e up here and 3 e's down there. Let's cancel that out. So when all is said and done, I get negative 1 over 2e squared. Pretty? No. Fun? Heck yes. All right, we've reached our nightmare scenario for chain rule. So let's remind ourselves what chain rule is. You're going to have some type of stuff on the outside and some type of stuff on the inside. The chain rule says take the derivative of the outside stuff. Keep the inside stuff the way it is, but then multiply everything by the derivative of the inside stuff like so. I'm going to rewrite this out. Okay, so f of x is going to equal, in parentheses to the 1/2 instead of one big square root of x plus 1 over 2x minus 1. Okay, now the derivative of the outside stuff is going to be power rule. Bring that 1/2 down. Okay, subtract 1 from the 1/2. Keep the inside stuff the way it is. And then multiply everything by the derivative of the inside stuff, which requires our good old friend, the quotient rule. So the quotient rule says that if you take the derivative of u over v, you get u prime v minus v prime u all over v squared. U would be my U. U would be my V. So U is x plus 1. V is 2x minus 1. The derivative of the numerator is just 1. The derivative of the denominator is just 2. And V squared is going to be the denominator squared, which I'm not going to FOIL out because I don't want to. And maybe something will simplify. I don't know. You never know. But we're going to multiply everything by this stuff and its combination. U prime V is going to be 1 times V, which is 2x minus 1, minus V prime, which is 2, U, which is x plus 1. And again, that's going to be all over 2x minus 1 squared. Okay, so what can I do here in red to kind of clean it up? What can I do? I can, well, negative exponent means you could take a fraction and completely flip it. So why don't we do that? 1/2. Take a fraction and completely flip it. So 2x minus 1x plus 1, right, to the positive 1/2. And now I could just make that a big square root again and everybody's happy. So I get 1/2 big square root of 2x minus 1 over x plus 1. I will leave that as that. What can I do with the purple? Well, I can distribute the 1, which changes nothing. So 2x minus 1. I can distribute the negative 2, so minus 2x minus 2. So that cancels out nicely. All over 2x minus 1 squared. And so that will leave me with negative 1 minus 2, so negative 3 over 2x minus 1 squared. So, look, I mean, you know, I don't know what else that we can do to clean this up. It's just a big mess. I mean, maybe, yeah, there's nothing I can do. I know the devil's going to tempt you to want to do something here, but no, you're in a square root. You don't want to change anything. You don't want to rip anything out. There's nothing you could do with the 1/2 and that 3 there. I mean, you're pretty much set. So really the only thing you could do is maybe combine these fractions and bring the negative out front. But I don't have space. I'm leaving it like that. But yeah, that's a mess. It's a mess of a problem. Quotient rule and chain rule is not going to be super fun if you have to do both, but we did. And we handled it just well with glee and joy. All right, like and subscribe. Use implicit differentiation to find dy dx in terms of y and x. When you're using implicit differentiation, what you're going to want to do is, let me rewrite this out and give myself a little bit more space. Okay, step 1 with implicit differentiation is you take the derivative with respect to x of both sides. So you d dx both sides, like this. When you take the derivative with respect to x, nothing changes. So on the left, the derivative of 4x squared is just going to be 8x, no big deal. Now, when you take the derivative with respect to y, you take the derivative as normal. So you would drop down the 3, multiply it to 2, that's a 6, subtract 1 from 3 and get 2. But if you take the derivative with respect to x of y, multiply dy dx to it. So you have to attach dy dx. Some teachers or professors might call that y prime. I like to call it dy dx because that's what it's giving me here. Okay. Similarly, the derivative of 4y would be 4. But since it's a y, you have to attach dy dx. So step 1 is you take the derivative of everything, right? And you attach a dy dx if you take the derivative of a y term. Now, what I do next is I'm going to group all of the terms with dy dx to one side. Happy news, that step is already done. So the next step, which would be like, I guess, step 3, is factor out dy dx. So I still have 8x on the left, nothing changes. Factor out dy dx, and when I factor out dy dx, that leaves me with y squared plus 4. Now, our job is to solve for dy dx. So we need to divide everything by 6y squared plus 4, 6y squared plus 4, right? That cancels out. And so you have dy dx, and let me flip things around to make it look proper. Dy dx equals 8x over 6y plus 4. And really the only thing that you could do here is notice these are all even numbers, so you can divide all of those numbers by 2, and you would be left with 4x over 3y plus 2. But that's your guy. You are looking at an answer with x's and y's in it because that's how implicit differentiation works. Fun stuff. Find the slope of the tangent line to the graph x squared plus 2y equals 11 at 3, -1. Now, the slope of the tangent line is a fancy word for derivative. The equation that I'm given, y is not all by itself. So I have to use implicit differentiation. So let me write out x squared plus 2y squared equals 11. Okay, these are the steps to implicit differentiation. D dx both sides. That means you are taking the derivative with respect to x of both sides. Okay, so the derivative with respect to x of x squared is just 2x, nothing fancy. When you take the derivative with respect to x of a y term, you still take the derivative. So drop the 2 down to 2, multiply them together, that gives you 4. 2 minus 1 is 1, so the derivative of 2y squared is going to be 4y. However, since we're taking the derivative with respect to x of a y term, you have to attach dy dx to it. Okay? Every single time. The derivative with respect of a constant is 0, so nothing crazy. Now my next step is I have to get dy dx all by itself. So let's subtract 2x from both sides, like so. That gives me 4y dy dx equals -2x. In order to get dy dx all by itself, I'm going to divide everything by 4y. So divide everything by 4y. Cross that out. And dy dx is going to equal -2 over 4, which is -1 over 2, so -1/2, right? And then x over y. Now this is dy dx. This is the derivative, which gives you the slope of the tangent line. However, I haven't plugged in my value yet. So if you're an x and you're a y, me finding the slope of the tangent line at that point is going to be negative x, which is 3, over 2 times y, which is -1. And that cleans itself up to negative over a negative, which is a positive. 3 over 2 is 3 over 2. My slope is that guy right there. Okay? So by taking the derivative, we had to use implicit differentiation. We did that. We plugged in our point at the very end, and we got positive 3 over 2. Dunzo. For each problem, use implicit differentiation to find dy dx in terms of x and y. All right, so let me spread this out a little bit. Let me give myself a little bit more space. Wow, this is not going to be pleasant at all. 4x squared y cubed plus 1 squared. All right, here we go. Buckle in. Implicit differentiation involves me taking the derivative with respect to x of both sides, like that. Left side, easy peasy, you get 2x. Right side, not at all. Right side is chain rule. And if you remember, chain rule has some type of outside stuff, in this case, squared. And then you have some type of inside stuff, in this case, 4x squared y cubed plus 1. In order to do chain rule, you take the derivative of the outside stuff, keep the inside stuff the way it is for now, and then take the derivative of the inside stuff. That's where it's going to be a killer. Okay? So the derivative of the outside stuff has me bringing down 2 and turning that 2 into 1, no big deal. Keep the inside stuff the way it is. So 4x squared y cubed plus 1. Now we are going to multiply everything by the derivative of the inside stuff. So I'm going to create my own section over here to do the derivative of the inside stuff because it's not going to be pretty. All right, so this is going to be the derivative of the inside stuff. The inside stuff was 4x squared y cubed plus 1. Taking the ddx of that, taking the derivative with respect to x of that guy right there, has me looking at you and saying, ugh, that's product rule. U would be my u, u would be my v, so I need to do u prime v plus v prime u. All right? So, the derivative of u with respect to x is going to be the derivative of 4x squared. Easy, 8x, no big deal. Multiply everything by v as is. So that would be y cubed, no big deal. The derivative of v is going to be the derivative of y cubed with respect to x. That's going to be 3y squared, but since we're taking the derivative of a y, you attach dy dx to it. Multiply that to u as is, so 4x squared. Okay? And then what we haven't done yet is the derivative of 1, which is nothing. So let's clean this up. So we've got 8xy cubed. 3 times 4 is 12. X squared, y squared, dy dx. So that's the derivative of the inside. So we're going to multiply everything to the derivative of the inside, which was 8x y cubed plus 12x squared y squared dy dx. I guess what we can do is, since I have this whole guy divided or multiplied to that whole guy, and my job is to get dy dx all by itself, let's completely eliminate the blue guy. So let's divide everything by 2, 4x squared y cubed plus 1, 2, 4x squared y cubed plus 1. Okay, all of that goes away, and fortunately the 2's go away. So on the left, we have x over 4x squared y cubed plus 1. That's going to equal just what's here in black, so 8xy to the third plus 12x squared y squared dy dx. Let's subtract this guy from both sides. So I'm running out of space here, so I'm going to do this. I'm just going to subtract, make it look like that. Okay. Sorry for the silence, there's just not much to say. And now, oh man, now I'm going to divide everything. Oh, this is a nightmare. Divide everything by u. Ugh. So maybe the best way to multiply that out and the best way to make that look, instead of dividing it, is by multiplying both sides by its reciprocal. I just think that'll look a little bit more pleasant. It's still going to be awful. It's still going to be so bad. But if I multiply both sides by 1 over 12x squared y squared, 1 over 12x squared y squared, I can maybe do some stuff, but I don't know. I don't want to do anything with this. I just want to leave it like that. So what an abomination of a problem. Dy dx is going to equal 1 over, I don't need that parentheses, not yet, I'll scoot you over, 1 over 12x squared y squared times the quantity x over 4x squared y cubed plus 1, so you'd have to distribute there if you wanted to, minus 8xy cubed. So that is the answer. It's awful. It's terrible. I mean, look at the original problem. It's going to be awful. It's going to be terrible, but we did it, and that is a possible looking solution. You could go further, but I won't because I don't have space. And these are my videos. I do what I want. But yeah, that's implicit differentiation that involved both chain rule and product rule. Puke. Thanks for watching, though. Like and subscribe. Use implicit differentiation to find dy dx in terms of x and y. So we've got 3x squared plus 3 equals ln of 5xy squared. All right, so let me rewrite it. 3x squared plus 3 equals, leave some space, ln of 5xy squared. All right. When we take the derivative with respect to x, the left side, easy peasy lemon squeezy. Okay? So the derivative of 3x squared, 6x. The derivative of 3, nothing. The right side is going to be chain rule and something else. So chain rule says you have outside stuff. Take the derivative of it. So the derivative of ln of blah is 1 over blah. Okay, keep the inside stuff as is, like so, but then multiply everything by the derivative of the inside stuff. That's going to require product rule. So let's go off to the side and find out what the derivative of the inside stuff is. We have the inside stuff is 5xy squared. I will call u and I will call u v. Okay, so the derivative would be u prime v plus v prime u. So I know what u is. U prime is the derivative with respect to x of 5x, which is 5. And v prime is going to be the derivative with respect to x of y squared, which is 2y dy dx. Now, when you take the derivative of a y with respect to x, you have to attach dy dx. So what now? Well, we have u prime v is going to be 5 times y squared plus v prime, which is 2y dy dx u, which is 5x. Okay, so we're going to multiply this guy to 5y squared plus 2y, and let's move this 5x over and make it dy dx. Let's just clean it up that way. And I probably could have multiplied 2 and 5 and made it 10, huh? Probably could have, probably should have, and I probably will in the next step. What I'm going to do first is I'm going to multiply both sides, though, by 5xy squared to get rid of u. Multiply both sides to 5xy squared. So that'll give me 30x squared y squared equals, nothing changes with the purple except I'm going to clean these guys up. So that's going to be 5y squared plus 10xy dy dx. Let's subtract 5y squared from both sides. Subtract 5y squared from both sides. So 30x squared y squared minus 5y squared is going to equal 10xy dy dx. Last step, divide everything by 10xy, everything by 10xy, and some simplifying happens, right? And we'll write it over here. 30, 5, and 10 are all divisible by 5, so 6, negative invisible 1, and 2. They each have an x. No, they don't. But they each, so the x's, there's no x in common. So x squared, x. But they each have a y in common. So y squared becomes y. Y squared becomes y. And y is now gone. And so that leaves us with dy dx equals 6x squared y minus y over 2x. Implicit differentiation, kind of painful, lots of fun. Like a tattoo or a nose piercing. Like and subscribe. Find dy dx at the point pi over 4 when sine x plus sine y equals tan x plus root 2 over 2. Ah! All right, so x's and y's floating around. This has got to be implicit differentiation. So what we're going to do is we're going to d dx both sides. We're going to d dx sine x, easy, sine y, equals d dx of tan x, easy, and I'm going to rewrite this as 1/2 x to the 1/2. All right? That's how I'm going to rewrite it. So square root of 2. Wait, no. That's just a number. What am I doing? That is much easier. Oh, praise the Lord. I don't know why I overthought that at all. All right, so plus root 2 over 2. I love it. Great. That makes life a lot easier. I'm glad I don't have to deal with that. That was my big grunt. My main grunt was from that. All right. Derivative with respect to x of sine x is cos x. No big deal. You know that. The derivative of sine y is cos y, but since we're taking the derivative of a y with respect to x, we have to attach dy dx to it. That's going to equal the derivative of tan x, which is secant squared x. Okay, no attachments because we're taking the derivative of an x with respect to x. And the derivative of a regular old number is nothing. That's why I was happy to find out that was a number. Now what we do is we get the dy dx all by itself on the left. So let's subtract cos x from both sides. Subtract cos x from both sides, like so. Cos y, that's a koi, it's a fish. Cos y dy dx is now equal to secant squared x minus cos x. Okay, divide everything by cos y. And let's not bother trying to simplify anything because I'm just going to end up plugging stuff in anyway. So let me write it over here. Dy dx is now equal to secant squared x minus cos x over cos y. Let's plug in our points. Move you over. All right. So dy dx with respect to that point is going to be secant squared pi minus cos pi over cos y, which is pi over 4. Now, secant squared is 1 over cos squared. So if I wanted to, if you don't have your secants memorized, here's a fun little trick. All right. This is the same as 1 over cos pi squared, right? And so we know what cos pi is. Give me a minute to complete writing things out. We know what cos pi is. Cos pi is -1. So this is going to end up being 1 over -1 squared, which is 1, minus -1 all over cos pi over 4, which is root 2 over 2. So that gives me 1 minus -1 is 2 over 2 root 2 over 2. Multiply the top and the bottom by 2 over root 2. Like that, and you get 4 over root 2, which if you wanted to, you could simplify. It would be 4 root 2 over 2, so it would be 2 root 2 when all is said and done. Right. But, you know, we're going to leave it like that. Or I'm just going to write this out because I said it. Like and subscribe, please, I beg you. What is the equation for the tangent line to the curve x squared plus y squared, a circle, equals 25 at the point -3, 4? All right, well, first off, Equation of the tangent line requires slope of the tangent line, which is the derivative. So let's do that first. Let's find the slope of the tangent line by taking the derivative. Now, the only way that you could take the derivative of this guy, or the easiest way that you could take the derivative of this guy, is by doing our good old friend implicit differentiation. So I'm going to d dx both sides. I'm going to take the derivative of both sides with respect to x, like that. Okay, so the derivative of x squared with respect to x is 2x, easy peasy. The derivative of y squared with respect to x is 2y, but don't forget to attach your dy dx. That's going to equal the derivative of a number, which is nothing. Now I have to get my slope all by itself. Dy dx means slope. So I'm going to subtract 2x from both sides, subtract 2x from both sides. That gives me 2y dy dx equals negative 2x. Divide both sides by 2y, divide both sides by 2y, and that gives you dy dx equals negative, 2 over 2 crosses out, negative x over y. Now, this is my derivative of the slope with respect to x and y. I can now say you were an x and you were a y. Let's plug those points in. So my slope is going to be negative 3 over positive 4. So 3 over 4. So what I have is a slope of 3 over 4. If I labeled you x sub 1, y sub 1, I can now think point slope thoughts. Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay. Plug in 4, so y minus 4 equals 3/4 x minus x sub 1, which is negative 3. So minus negative 3 is going to be plus 3, so let's save a little bit of time. Okay. So in order to find the slope of the tangent line, we had to take the derivative using implicit differentiation. I took my point, plugged it in, got 3 over 4. And when I got 3 over 4, I used the same point and point slope form to come up with an equation. Now, if for some reason you needed to do this and turn it into slope-intercept form, then distribute. You're going to get fractions. Add 4 to both sides. You're going to still get fractions. That's an option, but I'm sticking with this because that's good enough for me. Find dy dx when e to the y equals x squared over y. All right, so this is implicit differentiation. I'm going to d dx e to the y d dx x squared over y. Now the left side is not crazy at all. You take the derivative of e to the y with respect to x is still e to the y, but you attach dy dx to it. Okay? On the right side, you have quotient rule. Ugh. Quotient rule says that if you have a u over a v, you're going to have u prime v minus v prime u all over v squared. So u in this case is x squared. V is y. U prime is the derivative of x squared with respect to x, which is 2x, no attachments. The derivative of v is going to be v prime, and the derivative of v prime is the derivative of y, which is 1 with respect to x, so you attach dy dx. So really that 1 is not necessary, it's just dy dx. V squared is going to be y squared. Like that. So the right side is going to end up being u prime v, so 2x times v, so y, minus v prime, so dy dx, u, x squared, all over y squared. So let's do this. Let's multiply both sides by y squared. So we get y squared e to the y dy dx. Let's clean up the numerator a little bit. So we get 2xy minus x squared dy dx. I have to get both of my dy dx's on the same side. So I have to add x squared dy dx to both sides, add x squared dy dx to both sides. That crosses out and gives me y squared e to the y dy dx plus x squared dy dx equals 2xy. Let's factor out the dy dx from both of those terms. When I do that, I get dy dx times the quantity y squared e to the y plus x squared, and that still equals 2xy. Let's divide everything by y squared e to the y plus x squared. And I'm left with dy dx equals 2xy over y squared e to the y plus x squared. And that's all I have to do here. I mean, not that it's all I have to do. It's not an easy problem, not by any stretch of the imagination, but it's not like I have to plug in numbers or anything like that. We just get a really gross looking answer. And that's what you get. Fun. Let f and g be differentiable functions. If g and f are inverses of each other, g of negative 4 equals 7, and f prime of 7 is 2, then what's g prime of negative 4? Well, there's a little thing called the inverse function derivative formula. And what that is that says that g prime of x is going to equal 1 over f prime g of x. Okay, so if you're thinking that's kind of like chain rule, you're absolutely right. It is kind of like chain rule. So what do I know? Well, I need to find out what g prime of negative 4 is. So g prime of negative 4 is going to equal 1 over f prime of g of negative 4. So let's hope some magic happens. Okay, g of negative 4 is 7. So 1 over f prime, g of negative 4 is 7, so I'm going to replace g of negative 4 with 7. And f prime of 7 is 2. So there you have it. Inverse derivative formula. This is a very typical base problem for this section, so I hope you had as much fun as I did. Let f inverse of x be the inverse of f of x. That's equal to x cubed plus 3x. Find the f inverse's derivative at 4. Ugh. All right. Well, if I wanted to find what the f inverse's derivative at 4 is, I kind of need to find out what the f inverse of 4 is. So why don't I do the old switcheroo, call u y equals x squared plus 3x. Cubed plus 3x. Switch them like that. Make it 4. And it looks like, without having to do any math, if y was 3, if y was 1, I'd get 4. So y equals 1 is going to actually be a possible option for me. So I'm going to stick with that. I'm going to use the inverse derivative function rule, okay? If you forget what the inverse derivative function rule is, it's basically you have 1 over f prime of f inverse of x, like that, okay? So what I need to do is I need to take the derivative of u and then find out what f inverse of 4 is, which I already did, it's 1. So if I have the derivative, so f prime of x is going to equal 3x squared power rule plus 3 power rule again. So 1 over f inverse of 1 is going to look like this. F prime of 1. I don't know if I said f inverse of 1. I think I misspoke. Just don't want to do that. is going to look like this. 1 over, okay, 3 times 1 squared plus 3, which is going to be 1 over 3 times 1 squared. So 3 plus 3, 1/6. So kind of a gross problem. Inverses aren't a lot of fun when you deal with this stuff, but that's what you get. Let f of x equals 5x squared plus 1. Find the derivative of the inverse at 3, and then just for fun, square it. All right, well, we're going to use this rule over here. We're going to use the fact that if you have to do something like this, you're going to do 1 over the derivative of its inverse at a specific point. So we'll use that guy like that. What I need, though, is I need to find what the f inverse of 3 is, and I need to do that by taking the inverse of that guy right there. So I'm going to do the old y equals thing like that. Okay, I'm going to do the old switcheroo where what am I doing? I'm going to plug in, well, I'm going to swap these. So I'm going to do x equals 5y squared plus 1. Okay, I'm going to plug in 3 for x now. So 3 equals 5y squared plus 1. Subtract 1 gives you 2. 2 equals 5y squared. Divide by 5, so 2/5, and then take the square root of it. So one of my possible options, this is not pleasant at all, which is not going to matter anyway because you'll see there. But one of my possible options is going to be positive root 2 over 5. All right, so I'm going to go with that. So why don't I take the derivative? Why don't I take the derivative of f so I can use this? So the derivative of f is going to be just 10x. That's nice. And so the derivative of one of these guys, so root 2/5, is going to equal 10 times root 2 over 5. Now, I'm going to take that, and here's why, again, it didn't matter which one I chose because of the positive or negative. My job is to take that and square it. So whether it was positive or negative, either way, it's going to become positive. All right, so 100, or 10 times 10 is 100, right? Root 2 over 5 times root 2 over 5 is 2 over 5. And so that gives me 40 in the end. What a strange problem. I hate these. Like and subscribe. So after recording the video, I realized I'm not done. It's supposed to be 1 over this, so 1 over 40. So I am super sorry about the inconvenience and the weird choppiness of the edited video. That's my actual answer. Sorry about that. Still like and subscribe. I love you all. Find the derivative when you have an inverse trig function. No one likes these, but here's the derivative of the inverse sine. All right, d dx of inverse sine. By the way, you might see this written out as arc sine with a little arc in front of it. Same thing. Of whatever. I'm letting u be whatever is going to be the derivative of the inside. Okay, so the derivative of 3x, that whatever, over the square root of 1 minus whatever squared. So a little bit of chain rule action going on. You can memorize like 1 over this stuff, but I don't know, I would rather just go straight to the chain rule stuff because more often than not, you're going to have to use chain rule with this. So what this is going to look like is f prime of x is going to equal the derivative of the inside. So since the inside is 3x, the derivative is going to be 3 over the square root of 1 minus, in parentheses, 3x squared. So cleaning this up just a little bit more is going to be 3 over the big square root of 1 minus 9x squared. Now, if you're thinking, ooh, let's do difference of squares. It's not going to help us. I know you're thinking the right thoughts. Difference of squares isn't going to do you any good because they're going to be two different parentheses, so you can't take the square root of them anyway. So we're stuck with this. This is our guy. And our answer is not so bad. Not so bad at all. M&M. Find dy dx if y equals the inverse secant of the square root of x. All right. So the inverse secant's derivative is going to look a little something like this. All right, inverse secant of, we'll call it some random u, so this also incorporates the chain rule. You're going to take the derivative of the inside stuff, which is going to be the square root of x. We'll deal with that when we have to. In the denominator, you're going to take the absolute value of the inside stuff as is, and then a big square root of the inside stuff squared minus 1. All right, so let's look at this in kind of 3 parts. We have the u is going to be the square root of x, all right, because we have that. So the u is going to be the square root of x, but I'm going to call it x to the 1/2. Okay, so if looking at this at 3 parts, u prime is going to have me use the power rule, drop down the 1/2, subtract 1 from 1/2, and I get negative 1/2 as my exponent. Cleaning that up a little bit, that's going to look like 1 over 2x to the positive 1/2, and that's going to look like 1 over 2 times the square root of x. Hopefully you have this memorized or have seen this enough by now that you know this turns into that, but if you don't, no big deal. So that's u prime. The absolute value of u is just going to be the absolute value of the square root of x. Don't overthink it. But if I wanted to find u squared is going to be square root of x squared, which is x. So now that I kind of broke all this down and wrote it into different parts, y prime is going to be this put together. So the numerator is going to be 1 over 2 root x, and the denominator is going to be the absolute value of root x times x. So I'm not sure if it's even worth trying to clean this up and make this look a little bit better. Like, I know we have a complex fraction, but I'm going to leave it like that. I think that's okay. I don't know. Maybe in different problems you might be asked to do the reciprocal. So I guess if you were to do that, you would multiply the top and the bottom by 1 over absolute value of root x. So that would look like this. Y prime equals 1 over. You would have 2. You would have the absolute value of root x. You would have x. You would have root x. It's a mess. So, I mean, I guess all of these are okay, but none of them are great. So, I don't know. It's all good. As the kids say, it's all good. Like and subscribe. Hope this helps. Oh boy. Compute the derivative of f of x equals ln of x minus regular sine x plus arctan x plus 2 to the x. All right. So nothing crazy, like no chain rules or anything like that to deal with. Except for 2 to the x is a little bit of work, but that's all right. Ln of x, so f prime, let's just one part at a time. One part at a time. Okay, ln of x, 1 over x, no big deal. Okay, then we got minus sine x, so that's going to be minus cos x. That's not an inverse or anything like that, so I don't have to lose any sleep over that. This is why I have this section. Arctan is the same as inverse tangent, and so that's going to be, plus 1 over 1 plus x squared. Okay, memorize that. And let's get my purple marker out. Whenever you're dealing with 2 to the x, that's going to be b to the x ln of b. So I'll put 2 to the x ln of 2. So let's see if we can get rid of stuff. 1 over x is consistent with every thing, so that didn't help. But we have minus cos x, so you're plus, and so are you. So those guys go away, so C and E are no longer options. We have 1 over 1 plus x squared, so you're already done. You're gone now. And then my last option is going to be, even though it's backwards, 2 to the x ln of 2 is not u, so I'm going with D for that. All right. So lots, 4 different things to deal with, but the kicker for this one was the arctan, which is also the inverse tan, and that's what this section is all about. What is an equation for the line tangent to y equals the inverse tangent of x at x equals root 3? All right. The derivative of the inverse tangent of x is going to be 1 over 1 plus x squared. All right, so since I have this, right, I know that y is going to equal, or y prime, so y prime is going to equal that. I care about what happens at root 3. Now again, the equation of a line tangent means derivative, so that's why I did this. So now I'm going to plug in root 3, and what that will do is give me my slope of the tangent line. Okay, so my slope of this tangent line is going to be 1 over 1 plus the square root of 3 squared, which is going to be 1 over 1 plus 3, which is 1/4. So my slope is 1/4. All right, my slope is 1/4. Now what I have to do is it gives me an x value, but it doesn't give me the y value. Should I plug that into the derivative? No. If I want the y value, I'm plugging that into the original equation. So what I have to do is find out what y is when I take the inverse tangent of the square root of 3. So this is pre-calc stuff. And if you remember it, you get pi over 3. All right, so this is what I have. I have a slope now of 1 over 4, and I have a point where the x value is the square root of 3 and the y value is pi over 3. So using point slope form, all right, y minus y sub 1 equals m times the quantity x minus x sub 1. I can label um, it's already labeled. I can label ux sub 1, y sub 1. And that gets me y minus pi over 3 equals 1/4 times the quantity x minus the square root of 3. So y minus, not u, equals 1/4. So u, x minus the square root of 3, my guy is e. All right? So pretty tricky stuff. Okay, pretty tricky stuff. But yeah, there you go, inverse stuff. It's great time. Given the graph of f prime of x, and we know that f of negative 3 equals 6, find the equation of the line tangent to f of x at x equals negative 3. All right, so the equation of a line tangent involves us finding the slope to get our, like the derivative to find our slope, and then also using a point. This is my point right here. That's my x sub 1, y sub 1. So if I'm thinking, all right, well, let's do y minus y sub 1 equals m times the quantity x minus x sub 1 and do point slope form, you're thinking the right thoughts. We have our point, and there it is. What we don't have is our slope. However, we have the graph of the derivative, and the graph of the derivative is going to give us our slope at that point. So if I care about when x is negative 3, I'm going to go over here to negative 3 and find out that when I have negative 3, I have a y value of negative 2. So my slope is negative 2. So I have a point of negative 3, 6, so your x sub 1, your y sub 1, and a slope of negative 2, and it's just a matter of me plugging things in. Y minus y sub 1, which is 6, equals m, which is negative 2, times the quantity x minus x sub 1, which is negative 3. So just cleaning this up a little bit, that double negative is going to become a positive, and I get x plus 3. So I'm going to do that guy right there. So kind of tricky because you're going to want to think, oh, I need instantaneous rate of change, or I need the slope. No, nope. This is the derivative, so you just want the value when I quote-unquote plug in negative 3. And I got negative 2. And that's what you do. That's what you get. Fun stuff. Find the derivative of y equals x to the x plus 1, provided that x is greater than 0. The purpose of this section is to kind of think outside the box a little bit. So this is me thinking outside the box a little bit. I don't like that. But I have a little rule about ln's that if I were to ln both sides like this, right? If you have inside of an ln, or a log for that matter, an exponent, you're allowed to bring the exponent out. Okay, that's something you learned back in pre-calculus, maybe even algebra 2. So what I have is I have ln of y equals x plus 1 ln of x. Okay? And so if I wanted to, I can kind of rip this apart and say ln of y equals, let's distribute x times ln of x plus ln of x. Now, I haven't even started yet. I have to find the derivative with respect to x of this. I have to find out what y prime is. So I'm going to use implicit differentiation. So I'm going to ddx both sides. Now, when you take the derivative with respect to x, okay, of a y, like I'm about to do here, you do the problem regularly, but at any point when you take the derivative of the y, you attach a dy dx. So the derivative of regular ln would be 1 over, so this is going to be chain rule, so 1 over y times the derivative of the inside means I'm going to multiply dy dx. Okay? Equals. This guy is power rule. So let me go off to the side, okay, and say that my u is going to be x, my v is going to be ln of x, which means my u prime is going to be 1, and my v prime is going to be 1 over x, and I want to write out u prime v plus v prime u. So this becomes u prime v, which is going to be 1 times ln of x, so just regular old ln of x, plus v prime u, which is going to be 1 over x times x, which is 1. Okay? I'm also going to differentiate ln of x with respect to x, which is just 1 over x. Okay? Now, my job is to get dy dx all by itself. So I have to multiply everything by y to get rid of this 1 over y. So it's just going to be regular old distributive property. Multiply everything by y. So finally, dy dx is going to equal y ln of x plus y over x. Okay, so not the prettiest thing in the world, okay, not the belle of the ball, but, you know, that's how you do it. That's how I did it, so enjoy. Now, upon further consideration, I'm not quite done with this problem yet. I guess maybe since y wasn't in the original problem, it may not be the worst idea for you to rewrite this like this, so dy dx. Since y originally is x to the x plus 1, replace every y with x to the x plus 1. So this would be x to the x plus 1 ln of x plus x to the x plus 1 plus x to the x plus 1 over x. So I guess two different ways that you can write this out. I don't know. I like them both, but maybe this guy is a little bit better. Find the derivative of f of x equals 3 ln of x plus 4 ln of 2x. Now you might be looking at this and saying, oh, that's not that bad. I mean, that's regular and that's chain rule. But I think since this is this section, we're going to think outside the box a little bit. These are both ln's and I'm adding them. So why don't I just combine them into one single logarithm? So f of x, I could start out by moving that 3 up here and moving that 4 up here. So that would be ln of x to the third plus ln of 2x to the fourth, which, cleaning that up a little bit more, would be ln of x to the third plus ln of, what is that, 16x to the fourth. Now these guys, I haven't done anything, they haven't been added yet. When you add two logs or add two natural logs, you multiply the inside. So that's going to equal ln of 16x to the seventh, like that. Okay? So if that's f of x, then f prime of x is going to involve the chain rule. F prime of x is going to equal 1 over, keep the inside stuff, 16x to the seventh, but multiply everything by the derivative of the inside stuff. So 7 times 16 is 112 x to the sixth. Now simplifying this a little bit, 112 x to the sixth over 16 x to the seventh. I already know that that's going to be 7 because I just did it. And that's going to be over x because of the way that these simplify. Well, that was interesting. That was a lot of fun. Look at you. Find the derivative of f of x equals sine squared x times e to the 3x plus cos squared x times e to the 3x. If you're looking at this and thinking, ugh, product rule, but even worse because there's two sines, and product rule even worse because there's two cosines, and then chain rule, and then chain rule, oh, you're thinking about it all wrong, child. All wrong. You see, I look at this and I see a sine squared and a cos squared. That's ringing a bell. Another bell that's being rung is the fact that I have e to the 3x in common in both. So why don't I bring out e to the 3x by factoring it out and see that I'm left with sine squared x plus cos squared x and realize, oh, that's a Pythagorean identity. Sine squared x plus cos squared x is just 1. So f of x is e to the 3x. So taking the derivative is just chain rule. The derivative of the outside stuff is just still e. Keep the inside stuff, but multiply everything by the derivative of the inside stuff. And then you end up with f prime of x equaling 3e to the 3x. Short and sweet. That's how you do it. Find the derivative of g of x if you have x to the third power over x squared plus 1 plus 2x over 2x plus 1. So what I can do is I can combine these guys and make that x to the third power plus 2x. That's supposed to be a plus sign. That's really not a good looking plus sign at all over x squared plus 1. Now that is plus 1, not minus 1. Don't expect any magic to happen. Okay, so now we have to use product rule. Okay, so I'll call you u and I'll call you v. All right, so u prime v minus v prime u all over v squared is going to be our guy. Okay, u prime is going to be 3x squared plus 2. V prime is going to be 2x. V squared is going to be 2x plus 1 quantity squared. So g prime of x is going to equal u prime v. So u prime was 3x squared plus 2 times v, which was x squared plus 1, minus v prime, which is 2x u, which is x cubed plus 2x, and that's going to be all over x squared plus 1. Now, I'm probably going to regret this. Probably going to regret it. And I could probably say, we're done. But I'm going to FOIL this out. just because I'm curious, I want to see what happens. Okay, FOIL that out. 3x squared, 3x to the fourth. Okay, 3x squared. 2x squared, 2. All right, minus 2x times x cubed, so minus 2x to the fourth. And not looking good right now. Minus 4x squared. Okay. And that's still over x squared plus 1 squared. All right. You guys combine to make x to the fourth. You guys combine to make 1x squared. And you guys are 2. Yeah, so it was a waste. Oh well. I had fun doing it though. Like, you can't factor that out. Nothing special happens. You can't hope for an x squared plus 1 because that will not happen. Not here, not with these numbers. And I'm just double checking because I'm paranoid, but I shouldn't be because I'm right. X squared plus 1 squared. So We gave it a shot. We gave it the old college try. Found out that, nah, it's just going to be regular product rule with gross stuff attached to it. So there you have it. If f of x is 3 sine x plus 2 cos x, then find the second derivative. Okay. Let's see what's going on here. Well, the first derivative is going to be 3 sine x, so the derivative of sine is cosine x, plus 2, the derivative of cosine x is negative sine x. So let's clean that up a little bit. Derivative numero uno is going to be 3 cos x minus 2 sine x. Okay, now the second derivative is just me taking the derivative of that guy right there. So the derivative of 3 cos x is going to be 3 negative sine x minus 2 cos x. And cleaning that up a little bit is just going to be negative 3 sine x minus 2 cos x. And that, boys and girls, is all she wrote. There you have it. Dunzo. If y equals x minus 5 over x, then d squared y over dx squared, what is that? Oh, that's the second derivative. All right, so let's find the first derivative. And let me just rewrite out y because I'm going to need the space. Y equals x over 5 minus x. In order to find the first derivative, I need the quotient rule. So you're my u, you're my v. Quotient rule is u prime v minus v prime u all over v squared. Okay? U prime is going to be the derivative of the numerator, which is 1. V prime is going to be the derivative of the denominator, which is 1. And v squared is going to be the denominator squared, x squared. So dy dx, the first derivative, is going to be u prime, which is 1, v, which is x, minus v prime, which is 1, u, which is x minus 5, all over v squared, which is x squared. All right, so let's see if anything magical happens. Let's see if we have some simplifying going on. 1 times x is x, so let's distribute negative 1 here. So minus x, that's nice, plus 5, all over x squared. So derivative number 1 is going to be that 5 over x squared. Now to find the second derivative, I have to do the quotient rule again. No, I don't. I'm going to be clever here. I'm going to be smart. I went to college. I'm going to do this. I'm going to write dy dx like this because I can. 5x to the negative 2. And then I'll do power rule so I don't have to do quotient rule. Look at me being smart. Let me drop that negative 2 down. Okay, so d squared y over dx squared, or the second derivative, is going to equal negative 2 times 5, which is negative 10, x to the negative 2 minus 1, which is negative 3. And then that simplifies out to negative 10 over x to the third. Oh. So that started out looking like, oh, this is going to be a problem, quotient rule twice, and it could have been, but I didn't want it to be by doing it this way, so that's another way of doing it. Fun stuff. Find the second derivative of f of x equals sine x times e to the x. All right, so the first derivative is going to require product rule. So if you remember, product rule is u prime v plus v prime u. And so if I'm looking at this guy right here, u prime is going to be the derivative of sine x, which is just cos x. And v prime is going to be the derivative of e to the x, which is also e to the x. How nice. Now, the first derivative then is going to be f prime of x equals u prime v, so cos x times v, which is e to the x, plus v prime, which is e to the x, times u, which is sine x. So let's clean that up just a little bit. F prime of x equals cos x times e to the x plus sine x times e to the x. Okay? Now, the second derivative, I know what you're thinking. Ugh, product rule and product rule again? Nope. I already know what the derivative of sine x e to the x is because I just found it. So the second derivative, I'm not going to repeat myself by doing the same thing twice. I know that the derivative of sine x e to the x is cos x times e to the x plus sine x times e to the x because I just did it. Okay. What I have to do here, though, is, I'm going to have to do product rule for the cos one, but it's not going to be too dissimilar from what I just did. All right, you're going to be my u and you're going to be my v, so u prime is going to be negative sine x because the derivative of cosine x is negative sine x, and v prime is going to be e to the x, right? So u prime v is going to be negative sine x times e to the x plus v prime u is going to be e to the x times cosine x. And that's all still attached to this guy right here. Okay? Now wonderful things happen. Negative sine x e to the x, sine x e to the x, cancel each other out. E to the x cos x e to the x are the same thing. So f double prime, the second derivative, is going to be 2 of these cos x's times e to the x powers. And that, ladies and gentlemen, is the second derivative using product rule a buttload of crap of times. Find the third derivative of h of x equals x to the 5th minus 3x cubed plus x. So power rule, power rule, power rule. The first derivative is going to be 5x to the 4th minus 9x squared plus 1. Okay? Power rule, power rule, power rule. The second derivative is going to be power rule, power rule, power rule. 20x to the 3rd minus 18x, you're gone. Third derivative is going to be power rule, power rule. And that's going to be 20x squared minus 18. So a pretty lovely problem, just had to do some math. What is the second derivative of the function f of x equals 3x cubed minus 2x squared plus 6x minus 11 at x equals 2? All right, well, power rule a bunch of times to start us out, right? 3x squared becomes 3x cubed becomes 9x squared, jump the gun. 2x squared becomes 4x. 6x becomes 6, and negative 11 goes away. F double prime is going to be, power rule, again, 1, 2, 3 times. 18x minus 4, 6 becomes 0. Now my job is to find out what happens when x is 2. So f double prime of 2 is going to equal 18 times 2 minus 4. 18 times 2 is 36. 36 minus 4 is 32. So my answer is 32. Nifty! Oh my gosh! If f of x equals sine x, then find the 34th derivative? Wonder if there's a pattern. Well, all right, so let's do this. The first derivative is going to be cos x. The second derivative is going to be the derivative of cos x, which is negative sine x. The third derivative is going to be the derivative of negative sine x, which is negative cos x. And the fourth derivative is going to be, oh, no way, sine x. So this is just going to repeat itself. which means you're going to be the same as the fifth derivative, and you're going to be the same as the sixth derivative, and so on and so forth. So what would the 34th derivative look like? Well, the 34th derivative would basically, if I were to keep this process going, all right, 32 would be like down here somewhere because these are all the multiples of 4. So you would be 32, which means you would be 33, which means you would be 34. So the fourth derivative, 34th derivative, is the same as the second derivative, which is negative sine x. Huh. Interesting. I like it. If xy equals 5, find the second derivative. So this is going to require implicit differentiation. So let's write that out. Xy equals 5. All right, let's d dx both sides. d dx d dx. This is going to use the product rule. So if I have u is x, u prime is going to be 1. V prime is going to be the derivative of y with respect to x, which is 1 dy dx, or just dy dx. The power rule is u prime v, product rule, plus v prime u. All right, so on the left side, I get u prime v, which is going to be 1 times v, which is y, plus v prime, which is dy dx, u, which is x. That's the left side. That's going to equal 5, or the derivative of 5, which is nothing. So over here, I get 1 times y, which is y. So let's write this stuff over here now so I have a little bit more space. Y plus x dy dx equals 0. Let's subtract y from both sides. And x dy dx is going to equal negative y. Divide both sides by x, and dy dx equals negative y over x. All right, no big deal. But I have to take the derivative of again. So that's going to require quotient rule now. So u over v. So u prime would be 1. We'll have the negative attached to u. We'll keep the negative right there. So negative 1, because that does change things slightly. V prime is going to be 1, and v squared is going to be x squared. So the quotient rule, and let me write that up here, is going to be u prime v minus v prime u all over v squared. So d squared y over dx squared, the second derivative, is going to be, oh, did I forget something? I did. When I took the derivative of u, I forgot to attach dy dx. That changes quite a bit. Quite a bit. All right, we're good now. Which means I don't need that 1. Can I get the 1 out of here? Nope, that's the negative. I want the 1 out of here. Nope, that's the d. I want the 1 out of here. Yes, by 1. All right, much better. Okay. All right, let's clean this up. U prime is negative dy dx. V is x. Minus v prime is 1. U is x. No, is negative y. Oh my gosh, this problem's killing me. Over v squared is x squared. Okay. D squared y over dx squared equals, now wait a minute. How am I supposed to get dy? How am I supposed to do this? You know what? I know what dy dx is because I found it over here. Dy dx is negative y over x. So why don't I just replace those? Oh, how nice. And that allows these x's to cross out. Okay, so that's going to make life a little bit easier. Minus 1 times negative y is going to be plus y. Ooh, wonderful things happen. Over x squared. D, the second derivative, is going to equal negative y plus y over x squared, which is 0, over x squared, which is 0. Wow, who would have thought? Not me. I never would have thought. But the second derivative gives you 0. Interesting.